Everyone, I'm Ramanpreet Singh Papa, and I'll be discussing our paper on object detection server with different data distributions in this talk. The motivation is that essentially we have these public data sets that work really well with object detection performance. But once we look at these models and kind of try to transfer this knowledge over to robotic vision works, sometimes there's a big gap, and we want to highlight these issues and kind of motivate the future work in this area. So for this, we collected our chat dataset using our own mobile robot, which consists of various sensors such as Asus X-Time Pro camera, Sony IMX335 camera, and Master Check 4 camera. We used the RGB data from these cameras, and we divide the dataset into chat 1 and chat 2, and there's a significant distribution change between chat 1 and chat 2, such as radial distortion, the size of the objects that we're interested in, the number of images we contain, and so on. For our experiments, we basically use three state-of-the-art detectors, namely FastRCNN, SSD MobileNet P2, and YOLO V4. And the two classes that we're interested in are hospital beds and bed hotel. So in our first experiment, we basically train the models alone, and then we highlight that the models will work really well when trained and tested on the same dataset. But as soon as we transfer over this knowledge into a different dataset, the accuracy basically drops. So if we train a model on chart 1, accuracy on chart 2 is really low, and if we train the model on chart 2, the accuracy on chart 1 is really low. And these are some of the visual results. Then we perform some experiments where we basically add a little bit of data from the second data set into our training regimen. So we can use 100% chart 1 data and 10% of chart 2 data, and vice versa. And we show that this little bit of addition of data significantly improves the results across all various experiments we do. In fact, just having 10% data for each already gives us really good results. These are some of the visual results, and you can see that basically models trained on chart 1 will not perform very well on chart 2, and vice versa. And in our third set of experiments, which we call subsequent training, we basically take a model that was trained on chart 1 and then train it on chart 2 without retraining on chart 1 at all, and vice versa. And we show that the models that were performing really well on chart 1, now when they are trained on chart 2, the performance on chart 1 drops significantly. And same observations, we get the same observation when we perform the same experiments on public data sets. So in conclusion, we presented our chat dataset, we discussed the three state-of-the-art object detectors, and we perform experiments on the chat and public datasets to highlight the gaps that there exist in real robotic vision setting. And for future work, it's very critical to train these datasets on the new data that is arriving if it's from different data distribution, and also motivates our future work on semi-supervised learning and continual learning based integration for object detection. Thank you for your time.